Okay. We want to simplify these two expressions, okay? This expression doesn't factor. This expression doesn't factor. Okay, now somebody factored them. Factoring was a little bit off. I'll make you a note on the paper, but it's an easy error to make. Like that x plus 1 and x minus 6 or something like that, x minus 7 or something like that. Of course, that would give you the possibility. No. Unit factor, so there's no simplification. You can tell it doesn't factor if you use the discriminant using the quadratic formula. If it factored, then you'd have two factors equal to 0, right? Well, two factors whose product is 0, so that one of the factors would have to be 0. Okay. If you set this equal to 0 using the quadratic formula, you're going to get a square root of b squared minus 4ac. Actually, yeah, you do get zeros, but they're not going to be real. Down here, if you set this equal to 0, your b squared minus 4ac is going to be 16 minus 20, which is -4, and you can't do the square root of -4 in the real numbers. Up here, your b squared minus 4ac would be 36 minus 28. And you might have to write that out, just telling you, if you set either of these equal to 0 with the quadratic formula, well, this one going to give you a square root, the square root of a negative. This one won't, but you're going to get a square root of 8, which is not an image, okay? And that's going to tell you that it wouldn't factor. So in any case, neither of these factors. I was about to say this would give you a negative discriminant, but it isn't. Over here. Now this one does factor, and this does quite a bit of factoring. So we have x minus 3 times x plus 3 times x plus 4 up here. And in the denominator, we have x plus 4 times x minus 3 times x minus 3. So I want to cross things out. I don't allow that in this course. I don't allow that in courses before pre-calculus because some people cross out the x squares here and they cross out the x's. Okay, I see that a lot. And in a class where the majority of people who register for the class would do that or something similar. We just have to do it the way it really is, okay? And the way it really is this. We see that we have an x minus 3 and an x minus 3 here. Instead of crossing them out, we just put the x minus 3 over the x minus 3 in its own separate fraction. And then we have an x plus 4, but we can do the same thing. And then that leaves us the x plus 3 here and one of the x minus 3s. And now this is just 1 times 1 times x plus 3 over x minus 3, which equals x plus 3 over x minus 3. Now, this step from here to here, if we understand how to multiply fractions, I think everybody does, then we can verify that this is exactly the same as this. Okay? At least it'll have exactly the same values for any x. Because if you multiply out the three numerators, you get these three factors. Okay? So the three numerators here multiply out to something that's identical to this, except for the order, maybe. And order doesn't matter in multiplication. And same with the denominator. That's a crucial thing to understand. It's not something that's handed down on the stone table. It's not magical. It's just plain old common sense if you know how to multiply fractions. We can rearrange this into this form. This is one, and that leaves us this. So you need to write it out. Because crossing out your x squareds and crossing out your x's, it's an automatic no credit on that problem. Okay? You know, incorrect cancellation totally misleads you on the whole problem, the whole situation. So we can't have incorrect cancellation. Here again, we don't use it. Cancellation only works when you can do this. And you might be able to see, and you probably do, that, well, I could group this with this, so these can go away, and I can group this with this, and these can go away. When you get into Math 161, you want to do that, okay. In the college level course. Before that, we don't do it. Fair enough? Well, when it's fair enough, that's what it is, but I hope it's fair. Okay.